I have my mic on. All right, what's up? Let's do this. Oh my goodness, I remembered. I thought for sure I was going to forget. I remembered. Team formation due today. So get your team formation submissions in if you haven't. A few things about this. One, you have to have teams at least 4. If you're submitting the team formation form, you have to have at least 4. If you don't have 4, find another teammate, find someone in the class. The Piazza post to find teammates is open. You can use that. Use the Discord. Just shout after lecture. Be like, anybody need it? Whatever you got to do. But if you submit with 3 or less, I'm going to put you all on random teams. And just when I randomize, you might end up being on a team together. You might not. But I'm not going to have a group of 3 that just gets one extra person. It's just not really fair to that 4th person, so I'm not going to do that. To have them go into, especially if it's a friend group of 3, I'm not going to put a random person in there. So find a 4th. If you can't convince somebody to be the 4th, I'm not going to force somebody to be that 4th. Another thing, we have this awkward situation we talked about day 1, where you can get away without doing the project. So if you're planning to do that, like if you're set in your mind, you're like, I'm just not touching that thing. I'm not doing the project at all. If you could let me know, that'd be super cool. I did have somebody email me and said, hey, I'm just gonna not do the project. And gave me the courtesy so I don't put them on a random team and screw over a team who's actually serious about doing it. If you are, can you please, probably as I think the easiest thing, just as team names say, I'm not doing the project, and then your UBIT or something, just let me know, submit the form, or just email me. But let me know before midnight tonight, and then I just won't put you on a team. And then you won't be interfering with somebody who is trying to get an A and not just settling for the B. So if you can let me know, if you already know that's what you're doing, it's a lot better if I know, because the random teams could really get messed up if a lot of students aren't doing the project. So I won't hold anything against you. I won't judge you at all for it. Obviously, you'll get a 0 for all the project points if you're not doing anything. But just let me know as a courtesy to myself, to your fellow classmates, to the students, your would-be teammates who would get stuck with you, and then have you show up to the first meeting and say, yeah, I ain't doing nothing. Or, well, you wouldn't even show up to the first meeting. Why would you go to the meeting? You wouldn't even go. So just let me know one way or another. The easiest way would be through the team formation form. Just do your UBIT. I think, these are required, so just put a space for these or something. Something to let me know. I manually go through, after midnight tonight, I'm going to manually go through all these form submissions. So whatever you put there, as long as it makes sense, as long as it communicates your intentions to me, I'll get the idea. I'll figure it out. If you do have a team, my goodness, if you do have a team, you and your friends, you got together, you met people in this class, and you're intending to be a team, fill out the damn form. just fill out the damn form. If I get multiple submissions for the same team, that's fine. I manually go through these. I will figure it out. If I get 2 submissions with the same team members, I'll know that you're a team. So don't rely, if you're not sure that your friend submitted the form, just make another submission. Say, I don't trust that they actually submitted, and submit again. Just be sure that you're on a team by midnight. I like to process teams right away because if you're not on any team formation submissions, if you're not on any of these forms, I'm assigning random teams. So I'm taking everybody who's on a form submission, those are the chosen teams. Everybody else, and if you just want a random team, just don't do anything. And everybody who's not on a team, I'm going to put them on random teams. I'm going to group them together, and I'm going to try to do 5s as long as the numbers add up, groups of 5, and make random groups of 5 students. So if you don't submit this form by midnight and you have a group that you want to work with, you're not working with that group. You will not be working with that group because I'm going to go through my protocols. I'm going to form those random groups, and you're going to get random groups, and you're not getting the group that you want. And then you're going to email me tomorrow, and you'll be like, hey, we actually did have a group, and I'm going to say, sorry, random groups are out, that you can't do that. because then I'd have to destroy all these random groups and basically start over. I'm not going to do that to everybody. And I like to process these right away because if you're getting put on a random group, meetings start next week. You got to start meeting and talking about your project. So I want to get those random teams out there. I create the random teams, then I send an email to those team members and say, hey, you're a team. Get in touch with each other, whatever. I want people to be able to do that right away. And come on, man. I gave you till the end of week 4 to just fill out the form. Most of you don't need to hear this, and those of you who do aren't listening or aren't even here. But last semester I had 2 full teams emailing me the next day, oh, yeah, we're a team. We just didn't submit the form. Don't be those people. Just don't do it. It frustrates the hell out of me. I had 10 students all upset. Oh, we were teams. We just never submitted the form. You had 4 weeks to submit a form. Come on. And I split them up. I put them on random groups. I'll do it again this semester. So hopefully that doesn't come up, but if it does happen this semester, I'm putting on random teams. It's the thing that's fair to everyone in the class. Just fill out the damn form. Don't inconvenience everyone else, because I will inconvenience you instead if you're the one willing to inconvenience all the random groups. So I didn't mean to go on that much of a rant, but last semester apparently I didn't go on enough of a rant because 10 students... I'll do just a little bit more if you bear with me. Like, I get that you forget to do things. Like, I get that. I forget to do things sometimes too. But an entire 5 students over 4 weeks forgot to submit 1 form. Like, that's outstanding. Especially when I did this on the Friday last semester too. That means none of them paid attention in lecture. None of them looked at the course website to see the deadline. It was just astounding. I have no sympathy, especially after going through this just now. I have no sympathy if you don't submit that form. You're getting put on random teams. That's it. Oh, okay. Yeah, split up randomly. Yeah, find a fourth or split. You're getting split up. That one I do have some sympathy for. I get it. You're a team of 3 and you want to work together, but you just don't have that fourth. I have more sympathy for that, but I am still going to just put you in the random pool. Again, because it wouldn't be fair to whoever I add to your group. And maybe the 4th person wouldn't even mind. Maybe they would be fine with that. But I foresee too much awkwardness when you're 3 people who've been talking about the project or at least talking about something, maybe just gaming or something, for at least 4 weeks, and you just throw a 4th person in there. It's just an awkward social situation. I don't really want to put somebody in. So that's the reason of that. Plus the implication of in 4 weeks you couldn't find a 4th. I don't know. Do I want to force somebody to be in that situation? You had people drop out. Wait, somebody dropped out of the team, I hope you mean. Nobody resigned the course yet, thankfully. With such a long wait list, I get legit mad when people resign the course early in 312. Nobody has yet this semester, thankfully. I had somebody resign on week 2 last semester. Like, you just plugged up a seat that somebody really wanted. Yeah, I get the frustration, but if you can't find a 4th, I'm gonna split you into random groups, and you might just randomly get put together in the end, but it'll go through my randomizer. Yeah, I mean, if anybody's not on a team and wants to be their 4th, just message them on Discord. Anybody can be that. If somebody's willing to be that 4th, just message them right now. The situation can be resolved. But I'm leaving that up to y'all. I need at least 4 in the team submissions. Oh, okay. All right. So let's talk about homework 2. Today we're going to get through just about, with one little caveat, everything that you need for objectives 1 and 2. So you'll be able to get through all of the learning objective stuff. The one caveat being, and I'll mention this during lecture, that sometimes Chrome acts strange in the name of efficiency, I'm pretty sure. So there's one thing that you'll kind of need the buffering content, which is more of an application objective 1 topic, that you'll need some of that for for learning objective 2. But we're going to do file uploads today. So let's do exactly that. Let me get this queued up. Multi-part parsing and file uploads. Okay, so last time we saw this multi-part form data. We saw this way to be able to submit forms in this multi-part encoding. And today we want to talk about that pretty much all day. So when we send a request with this multi-part form data, we get this monstrosity. And for homework 2, especially application objectives 1 and 2, your task is to parse this. Then you'll have your parsing code for the application objectives. You already have the parsing code. And you can just use it. But we want to parse this data. So when we get this multi-part form data, we're going to get this special content type, including a boundary, and then each part of the body is going to be separated by that boundary. Each part's going to have its own headers and body, basically like a mini HTTP request or response, an HTTP message. And the content length, as always, is going to be the number of bytes in the entire body. This is required for file uploads. I mentioned this last time. If you have a form that's not multi-part form encoded, you can't upload your files. You may have ran into this if you did web development on your own. You had a server and you're going through the tutorial and it says this is how you handle file uploads at a specific path, and then it just doesn't work. And you realize in your HTML, you have to set encoding type 2 multi-part form data, or else you never get the files. At least I made that mistake when I was first doing web development. So this is required for file uploads. We need that multi-part form data encoding type, or else the file is not sent. And to support file uploads on the front end, aside from setting the encoding type, we take our input, which were both text last time, and we change text to file. Front end supports file uploads. That's it. We change the input type to file. When you change this to file, you'll get the file picker of your browser. You click on upload. It'll give you an upload button. It'll open up your file system. You pick a file. That's all built into the browser on how to do that. So it'll look different on each browser, but and operating system. But you don't have to code any of that. It's just built in. You just use the code that exists. So you change type to file, and this is a file upload now. That's it. That's the front end. Of course, we're always interested in the back end in this course anyway, so it's fine that the front end's pretty easy. So file uploads, we send that in a post request, and the body of the request is going to look something like this, where we're going to have the file name that was uploaded and the bytes of the file in this request. So your goal, when you get to learning objective 2, is to get a request like this, headers omitted, of course, extract the comment, it'll be comment, not commenter in the homework, and extract these bytes of the file, save these bytes to a file. The bytes of the image will be here. You save that to a file, and then in your database, store the file name and the comment. I don't think I mentioned it in these slides, but in the homework doc I do. This file name, you can pretty much ignore. You don't care what the user's file name is. This is whatever the name of the file was that the user uploaded, which generally isn't that helpful to us. You'll come up with your own naming convention. I'm fine with image1.jpg, image2.jpg, image3, image4, etc. If you want to do hashes, like if you ever view an image like anywhere on the internet, you're going to get this big long hash value that doesn't have any real meaning or anything. It's just a unique ID for that image that's randomly-ish generated. If you want to do those, that's fine too. But some naming convention that you control. The issue is, okay, I uploaded discord2.png. What if some other user of the site also uploads discord2.png? Now what? So you can't really use these names that users provide because it's just going to be all kinds of issues. You could store that somewhere. We're not going to for the homework, but you could store that somewhere just as a nice to know kind of thing. Maybe if the user downloads it, you want to call it that again. But we're not really interested in their file name. Name, upload, this is going to match the form, whatever name you give it here. So you do want to read that to make sure you got the right multi-part part. So how are we going to do that? There's one big, I shouldn't say problem, but one big difficulty that makes homework 2 significantly harder than homework 1. I mentioned that in class, right? My note at the top, I did on Wednesday, right? Significantly harder than 2 is that images are not strings, right? Hopefully I said that enough and waved my arms enough. Images are not strings. Images can't be encoded using UTF-8. For homework 1, you have to read the file as bytes and then append the bytes to the end of your headers after encoding the header as bytes. They're bytes. They can't be concatenated as strings. They can't be parsed as strings. They're not strings. They're bytes. But in the middle of this big HTTP request, this multi-part form request, we have a bunch of bytes that can never be treated as strings. Yet we still have to parse this request. In homework 1, you get the request, you receive the bytes of the request, and you immediately say decode. You convert the entire thing to a string, and then you do some string parsing. It's not going to work when you got an image in that request. Because once you hit decode and there's an image in there, you get a decoding error. At worst, your program crashes. At best, you corrupt the bytes of the image, and you don't recover the actual image anymore. So we need to parse this request without converting it to a string, or at least very carefully converting it to a string. So how do we do that? That's our big challenge. Let's just go through this step by step. I feel like that slide was missing my punchline. On a later slide, but I want to say it now. So on homework 1, it was all string parsing to parse these requests. Homework 2, how are we going to parse when we can't do string parsing? We're going to do byte parsing. We're moving down to the byte level because we can no longer reliably just work with strings. So byte parsing, and spoilers, homework 3, I already mentioned this in class, but now it's more relevant to us. Homework 3, we're going to get all the way to bit parsing. It's pretty much the progression of this course. Bless you. String parsing, byte parsing, bit parsing. Then homework 4 is kind of back to string parsing, and we kind of take it easy on homework 4. So how are we going to parse this thing? First, we're going to check the request, the method type, and the path. We did that in homework 1. That's old hat. You know how to do that. So we get a post for our form path. This tells us that we need to run our multi-part parsing code. We're going to read the content length, which is going to be the number of bytes that we have to read in the body. So every request and every response is going to have I'll stick with requests here. Every request is going to have a request line, any number of headers, and then a blank line, and then the body of the request. So after that, CRLF that's sitting right here, after that, we're going to have, in this request, 9,937 bytes of data. So we want to make sure we read that many bytes after this CRLF right here. So starting with this dash is the byte number 1 of the body, we're going to read 9,937 bytes. It's going to be very important. There's a whole lecture on it next week, so I'll cap it at that for now. This many bytes of the body. This might include calling receive more than once. That one I'll leave it at that. So content type, this is going to be multi-part form data. That's the type of the content. That's the MIME type. And then we're going to have an extra piece of information, a boundary. You want to read this boundary. I see so many students in office hours with really strange bugs, and most of them are because they don't read the boundary. They're just like, Well, it's going to start with, everything's here is going to start with 6 dashes, so they just look for that without reading the header. And then they have some crazy bug because it doesn't work for them. So actually read this, please. And then we want to read this and then look for that. In the body, we're going to split on that boundary to get the parts that we're looking for. Each part is not going to contain the boundary at all. And each boundary is going to appear slightly different than it appears in the header. So in the header, you get what the boundary actually is, and then each boundary that separates the data is actually going to start with dash, dash, and then the boundary. I don't know why. I'm sure there's a good reason why, but it's not just straight up the boundary. It's dash, dash, boundary, and a CRLF. So there's a CRLF at the beginning here, so this won't be on the same line as the last line of the content that comes before it. For the first boundary, there's already a CRLF here, but it will start with a CRLF because it's already there to specify the end of the headers. The last boundary is even more special. It also has a trailing dash dash. Notice that there's no CRLF at the end of the boundary. At the end of the last boundary, there's no CRLF right here. There is, did I mention that on the other ones? There is a CRLF at the end of this one to start the headers, though. So once we find those boundaries, we read the boundary header, we append that dash dash to it, look for each instance of that, knowing that it's not, those bytes of the boundary are not contained in any of our content, so we can safely split on the dash dash boundary. We can split our data on that and then parse each part separately. If you are splitting, just note that your last split is just going to contain dash dash. So you should have some way of ignoring that last dash dash, some way of handling that. But you will have a split that's just dash dash. So each part is going to look just like an HTTP request. It's going to have any number of headers, one blank line, our CRLF, and then the actual content of that part. The headers are going to at least include a content disposition, if in our case is always, but if it was submitted from a form, we're going to get this content disposition. It's possible to not have this in a multi-part request, but not if you're using an HTML form. So content disposition is going to have form data, because it was submitted by a form, and then the name of the input for this value. So commenter, that matches my name on the input in HTML. I said name equals commenter. So on my multi-part form request, I get name equals commenter to say this is what the user typed in to that text field. The other one, name upload, I had my input of type file named upload. So I get to know that this was the upload. And then for the image, I'm going to get a content type as well. I uploaded a PNG, so I get the content type image.png, which my browser figured out. It looked at the file and said, this looks like a PNG. I'm going to set the content type to image PNG. If there's no MIME type, if there's no content type, it's text plain. So this was a text form. No content type, default text plain. So Jesse, I just typed plain text in the form. Notice that there's no content length in your multi-part, in each part of your multi-part request. The whole purpose of content length is to make sure that you read exactly the entire request. So when a browser or when you are parsing a request, you're going to look for this CRLF right here. Everything before that's headers, and everything after that is the body. But there's nothing to specify the end of the body. There's nothing that says, here's a special character. This means that we're done with the body. We're done with the bytes. Partly because how would you guarantee that special character isn't contained in the body of the request? we do special work to make sure this isn't contained in the body of the request. It'd be a hassle. So we do content length. So whatever after the CRLF, that many bytes. So now we know read that many bytes and then stop. After that, we have the entire request. We don't have the same problem in these parts because when we're parsing these parts, we already have the entire request. We know we have all of the data that we're looking for, so we don't need content length to tell us when to stop. We're going to stop when we find the boundary again. There's no need for content length, so we don't have it. We don't want to have stuff that we don't need. We don't want to do extra stuff. And then the bytes of our file that we want. Never, 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 never encode a file that's not a text file as a string. Never do it. You can't do it. We're handling images. Images are following, in this case, a PNG protocol. We're following PNG file format. It's not going to be valid UTF-8. I hope I've made this point enough. I think I have. It's not going to be valid UTF-8. So we can't change the bytes of the file into a string. We can't parse this as a string. We can't do it. I'll still see a lot of you in office hours parsing bytes of a file as a string, which is fine. You do it on accident. I see that a lot. But if you're intentionally parsing the bytes of the file as a string, we got some talking to do. I got some things to say, because I say this all the time in lecture now. So how do we do this? How do we parse this whole thing without converting it to a string? I can't just read all this from my TCP socket, convert it to a string, and start parsing because I just blew up my image, my file that was being uploaded. It's parsing bytes. I got excited and blew the punchline earlier, but parsing bytes. So we're going to parse this in bytes, not as a string. So we're moving on to byte parsing. So how do we do that, though? So when you receive a request, you receive it as bytes. You can't receive it as a string because the internet would break. Like you have to receive things as bytes. You can only send ones and zeros over the internet. So we receive it as bytes, and Python or any language that you're going to use isn't going to automatically convert that to a string for you because, well, what if you're uploading a file? So you receive it as bytes. So it's already in bytes, and your goal is to just not convert it to a string. Once you convert it to a string, either with decode or any other way that you're converting it to a string on accident, it's going to break. So we can use subarrays for this. And if you are using Python, this is another one of the things where Python just doesn't get in your way. It makes it pretty easy to do this. Python, you can split arrays into subarrays pretty simply. You can do like the brackets, and then like 0:20 would give you the first 20 bytes of the array. You can do subarrays pretty easily if you know the indices of where you want to split things. So subarrays, to be able to chop up the bytes. And the first thing we're going to do is find the headers. So we're going to look for that /r/n/r/n. The first occurrence of that is going to indicate the end of the headers. It's a very special thing in an HTTP request or response. That first blank line says, we're done with headers. That's why even on your redirects, if you don't have that /r/n/r/n at the end, the browser's going to hang because it's saying, oh, you must still be sending me headers because you didn't send me that special sequence or secret code that says you're done with the headers. I didn't see that. You must have more headers for me. I'm going to sit here and wait for those headers. So you have to have that. And now in your parsing code, you see the other side of that. If you get a request that doesn't have that /r/n/r/n, your code's going to break because you need that character has to exist in every single HTTP request and response. It has to be there because it's how we indicate the end of headers. Because there's no content length for the headers, we don't have another way to tell that the headers are over. Yeah.
Do we have to write?
To search the byte array, you can use find. There's find in Python. So that byte array, Python is really nice for this. Byte arrays basically act as strings. You have a lot of the same functionality. You have a split method. You have a find method. You have a reverse find. You can subarray by indices. Really makes it nice. So we find that special character, that special sequence of bytes, and we say, okay, everything before that's headers. And it's important, I gotta mention this a few times, it's important that you find the first occurrence of that character. Say you're splitting on /r/n/r/n/n, it gets to be a mouthful. That's going to occur in this example 1, 2, 3 times. So you're going to get 4 different parts when you split like that. But the bigger danger here is that the bytes of the file can include that as a subsequence of bytes. So you might be chopping your file in half too, which is clearly bad. It's a bad thing. So once you find that the first occurrence of this, you take everything before that, those are headers, and guess what? Headers have to be ASCII. So once you extract the headers, now you can decode and throw that. Hopefully did I give this advice yet this semester? Hopefully you wrote a method in homework 1 to read and parse headers and put them in a key value store or a dictionary in Python. And you just call that code. You do it the same way that you've done it with every other request. You throw these headers into that parsing code and get all of your headers extracted, get the method and the path. Well, you already have to read that by the time you get to this part. Or actually, you can just do that every time you get any request ever. Parse all this and get it in some data structure, get that data in some way. Ideally, by using classes, create an object with all the fields that you need. Parse all this as strings. Cool. You got that separated from the danger part here, so you can parse that as a string. You want to parse all your headers and read this boundary. But now this boundary is a string here. You can parse this as a string, but there's still bytes down here. So how do you look for this boundary in the body of your request? Well, we're going to encode the boundary into bytes. You know how to encode. You know how to convert a string into a byte array. So we're going to convert it to a byte array and then look for that sequence of bytes in the body of the request. And like I mentioned, if you're using Python, you take this byte array, you'll have this in an array of bytes by this time. You'll have this in an array of bytes because you'll encode it. And you do .find. That's going to give you the index of the first occurrence of that subsequence. And then with that index, you can do more array splitting, more splicing, find all the occurrences, write whatever code you're going to write. You're software engineers at this point. You can write that code to get all of these parts separated from each other. Then when you have a single part, you're going to look for that new line, that blank line sequence, CRLF, and do the same thing as if this were an HTTP request. Find the first occurrence of CRLF. Everything before its headers, those can be parsed using ASCII, convert it to a string, and take whatever's after the CRLF, and just store that for later as the bytes of the part, of the body of the part. Look at the headers. Try to figure out what this is, what part this is. For that, specifically the name we want to read. Figure out what the name is for this. Is this the image, or is this the comment? Or on your application objective 2, is this my cross-site request forgery token, CRL? Cross-site CSRF. I always get that one wrong. I know what it stands for, but not the acronym. Usually it's the other way around. And figure out what the name is to figure out what this data actually is. For the comment, you'll know it's a string, and then you can safely parse that as a string, store it in the database. For the image, once you have this isolated, you know it's the upload, you've isolated these bytes. Now you're ready to actually handle the file. Again, never converting it to a string, but just take these bytes, create a new file, write those bytes to the file, and you save that image. Give it a file name, image 1, image 2, have some way to keep track of what image number you're on, and save that image to the file. And now we support file sharing. You effectively have a file sharing site. For the homework, it's going to be an image sharing site, an image bulletin board. but from a TCP socket only, by the time you're done with homework 2, by the time you're done with learning objective 2 on homework 2, you're going to have a file sharing site where users can upload images and share those images with other users. Oh, that's Monday's lecture. I did misspeak at the beginning of lecture. You can't quite get those done because we haven't talked about HTML templates yet. We do need Monday's content to get done with learning objectives 1 and 2 before you can display those images to all users. But you can support the uploads. There's plenty enough to keep you busy by Monday, before Monday anyway. But we support file sharing. So any questions on any of that? Everyone's ready to parse multi-part form requests? Bless you. How do you make it secure? Good question. How do you make this secure? Wow, that just happens to be what I'm going to talk about. Okay, so we host files now. Let's just move on with lecture question. We now host arbitrary files. On homework 1, we were hosting files, we were hosting the images, but it was a fixed list of images that we were hosting. You knew which ones you were hosting, and you could hard code those paths in your server, and that was fine. For homework 1, it's whatever. Like that's about what I expect for homework 1. For homework 2, we can't quite do that because you don't know like how many images are going to be uploaded. You can't hard code all these paths. If you say you hard code 20 paths and your users upload 21 images, you're going to go back and edit the code of your server to add that 21st path. Like it just doesn't work anymore. So we need to be more dynamic with our pathing, and we need to host a path when we have our image path. What I recommend just doing it like this: image slash, the way we set it up on homework 1, just expand that. If you did this in homework 1, you're already ahead of the curve on homework 2, is have get slash image slash, and then whatever comes after, read that as a file name, look for a file with that name, read it, and then send the bytes of that file. So instead of saying if path equals slash image slash flamingo.jpg, you're going to say if path starts with slash image slash, then take anything that's after the second slash, take that as the file name, go to your file system, open that file, and append those bytes to the end of your response. So we got to be a little more dynamic here. If you get a request for an image that doesn't exist, I'm okay with whatever behavior you have. I don't think I put that in the... by the way, anything I put in the testing procedure in the homeworks, like that's what we're testing. I don't have any secret notes that I hand the TAs and say, hey, this is how you actually test it. Like that's the same stuff that I give the TAs. I put it on the homework doc for transparency. Instead of just giving those to the TAs, I give them to everybody so you know what we're testing. Anything I forget to put on there or anything that I just don't put on there at all is not fair game for testing. So I'm pretty sure I didn't put any 404 stuff in the image testing. Therefore, you don't have to handle 404s for an invalid file name as an image. But in the practice, my slides are always like, in practice, in the real world, what should you do? You should respond with a 404 if there's an invalid username. I just don't make you do it on the homework because the bulk of the homework is how do you parse these multi-part forms and then host all that content with HTML templates. I think that's enough stuff that I don't have to just keep piling on. Is there a question that I saw here?
Just asking, like, you talked a lot about like scrubbing inputs that you get. Mm-hmm. So if you don't like
yes, but there is one thing that I explicitly do say, and that's the security thing we're about to talk about. But if you don't send a 404, if somebody makes a request for like poop.png and you don't have a file with that name, you can just, I don't know, if the server crashes even, that's fine. Because if it's not in the tested procedure, we're not going to test it. So we just wouldn't find that bug. But there is a security issue. You're going to have some path, slash image slash whatever. And if you want to set up your pathing different, like I mentioned, but just sticking with the way we set up on homework 1 is what most students end up doing, which is what I would expect you to do. But if you want to use query strings, like I mentioned on the last slide, fine. But assuming you're doing it with just the paths, slash image slash file name, you go to your file directory, you open up a file with that name, and then send it to the user, right? Makes sense. And then some user sends /image/tilde/.ssh/id_RSA. You parse that, you take that as a file name, you go to your file directory, you open that file and send them the contents of that file. And oh shit, they just got your private encryption key. And now you just got hacked, you're screwed, whatever they want to do with that, they're going to do. They're going to find some way to attack you. So we have to be careful with this. When we're hosting paths that take some parameter that users can set and users can abuse, and if I haven't said this enough this semester yet, never trust your users ever, 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 ever. Never trust your users because they will try to attack you, is you can't trust this file name that they put in the path. You can't just say, oh yeah, whatever they put after /image/ whatever they put after that, yeah, I'm just going to take that and run some code and open a file. No, we don't want to do that. So for your homework, this is a security issue. It is in the testing procedure. It's labeled red security and everything. So this absolutely you have to do. The first line of defense and what I expect on your homework, remove all / characters. And if you get too fancy with this one, don't just be careful. Make sure that you're still protected against this, no matter what you do. I have some students build really fancy pathing for their web servers, and then they can accidentally expose themselves to this because they don't have a simple way to fix the pathing in this way. But if you get this request, read this as a file name, and then replace all / characters with empty string, effectively removing them. Now an attacker can't navigate your directory structure. They have to only access files that are in the images, wherever you're storing your images, which should be a subdirectory of your project. And they can only access files in that directory, which means they can only access images, which is what we want them to access. So make sure they can't get out of your directory structure and do some silly things like this. Either that or whatever you want to come up with to be able to prevent them from accessing arbitrary files on your hard drive. It's a very big vulnerability if you're vulnerable to that. And if you want to build some really strong defense, you can keep track of a list. Every time a file is uploaded, you keep track of that file name, and you say, if I get a request for /image/ something, and that something isn't in my list of valid images that I host, send a 400 not authorized. 400 level, 401, 403 not authorized. I always get my HTTP codes mixed up, man. I can't even say the right acronym. And don't forget to disable MIME sniffing. MIME sniffing, this is the case that I brought up when we talked about the no-sniff to begin with. We handle image uploads. We don't want somebody uploading JavaScript code and then us hosting that to our users and having that JavaScript code run. So we're going to set our MIME type to image.jpg. It's okay if you only handle JPGs for your homework. If you want to add PNG, that's fine, but it has to support PNGs. That's what we're testing with. So we set the MIME type, we set the no sniff, and then if somebody uploads JavaScript, there's no concern about that JavaScript running in the browser because we got the MIME type right and we got the no sniff set. Okay, any questions at all? I think the TA's got chat covered. Does it matter where we store the files? Not really. Oh yeah, you got it covered though. All right, any questions on any of that? Quite a bit of stuff. We get file uploads now. It's bonkers. With no framework. File uploads with a framework is whatever, but file uploads with no framework. When you get done with homework 2, that's a big accomplishment. Okay, let's run a server. This server, like the other servers I show in class. By the way, I've had semesters where I showed too much code in class and it just caused lots of issues. So I show very little code until later in the semester now. But this does nothing. But I am doing a little something here. I shouldn't even show this because I have seen. Look, someone's taken a picture of it already. I'm going to see this in office hours. It's going to be at office hours. This is wrong. This is not what you're supposed to do. Oh. I hate what I show code in office hours, and it's just character for character comes back to me in office. I show code in lecture. Character for character comes back to me in office hours, and I'm like, that was an example that I was showing to prove one specific point, not exactly what you need to do on your homework. And then they stare at me like, wait, so why doesn't it work? Oh, frustrates me. Think about what you're doing. This is my recommendation. But this is the same code that I already showed in lecture anyway. I just have it in a while true. I don't like showing that because I'm going to see while true in office hours, and that's wrong. It's going to break. It's an infinite loop, obviously. It's an infinite loop. But I just want to keep calling receive on the same TCP connection. I'm going to explain why next Wednesday when we talk about buffering, why that's important. But anyway, Python 3, server 2, run this thing, doesn't do anything. Let's go to the browser. And I do want to, actually didn't show this before. When I have this server running, but I don't have it hosting anything. Obviously, it just responds. I think it responds with hello, or I don't even think this one responds with anything. But I do want to test it. So I'm going to write some front-end HTML. And as the action, instead of giving it a relative path, I'm going to give it an absolute path, which is going to send this request to the server that I have running. My server is running on port 8000, so I'm going to send an HTTP request to localhost 8000 and just whatever path. It's going to be a post, multi-part form data, and it's the same thing that we saw in lecture. I'm going to open this. I already have it open, but I'm going to open this. Actually, it might be worth going through that way. I'm just going to open this as a file. I'm going to open. Just double-click the HTML. That's it. This form is coded, as we just saw, to send it to my server, and I'm going to upload a file. And I'm going to upload carefully the smallest JPEG here, the rabbit, and submit. I'm waiting for it to load. I know it's not going to load. And I can see what oh, no, I lied. There is a CRLF at the end after the last boundary. Is that true? It has to be. It's right there. Damn it. There's a new line at the end. Sorry. And we can see what we actually get in the request. So I have this constantly reading 2848. This means I'm going to read at most 2848 bytes from the request, from the TCP socket. And I can see that it's constantly reading 2048 for a while. And these are going to be the bytes of the image. It's all hex. It's not valid ASCII. It's not valid UTF-8. These are bytes of an image. And then when I get to the last one, I'm printing out how many bytes I read. And I only read 640.